Okay, with this one, guys, it says given f of x is equal to 2x plus 5, given g of x is equal to 3x plus 3, when does f of x equal g of x? So what we could do, guys, is we could actually, we could take out our graphing calculators, we could graph both these lines, 2x plus 5 is a line, we could graph 3x plus 3, and then we could look and see where they intersected, and we could use our graphing calculator. But I wanted to do this one by hand, because sometimes it's almost easier by hand, really. So it says given f of x is equal to g of x, that would mean where do they equal each other, which would be where they intersect if you're going to go the calculator way. Otherwise, let's just do the algebra. So f of x is equal to g of x. So f of x is equal to 2x plus 5. So we have 2x plus 5, which is equal to g of x, and g of x is 3x plus 3. Now on the left I have an x, on the right I have an x. Now we can combine those as long as we use the correct operation to get from one side of the equation to the other. So I'm going to go ahead and combine my x's, but I've got to subtract 2x from both sides. Now remember, you can check your algebra here because those better add up to be 0, and they do. So we have 0 plus 5, which is just 5 on the left, which is equal to 3x's minus 2x's is positive 1x's, or just x, and then we have x plus 3. Our goal is to solve for x piece by piece, so now I'm going to get x alone by subtracting 3 from both sides. If I add up 5 minus 3, I get 2. So 2 is equal to x. Once again, check your work. Does positive 3 minus 3 equal 0? It does, so x was truly alone. So x is equal to 2. Now, if you would have done it on the graphing calculator, you would have graphed the lines on an xy plane. On your calculator, you would have graphed them, and you would have seen where these two lines intersect, and they would have intersected at x is equal to 2. Almost the algebra was easier on this one. Now, keep in mind, on the quiz, I had people asking me, well, how should I know if I'm going to have 1 or 2 solutions? So I'm going to bring us quickly to think about that. So in the beginning, we had a linear function, linear meaning x to the first power, and then we had 3x to the first power. So we had 2 linear functions. Now when we simplified them, we were here, we simplified them and got to here. Now notice it was still to the first power. So when we simplified, it was still degree 1. So this means it's going to have 1 point of intersection, or 1 solution. So let's say we had a quadratic, meaning like an x squared. So let's say we have something like this. X squared plus 3x plus 3. And let's say we would have set it equal to x minus 2. Now when we simplify this one, let's bring everything over to one side of the equation. So we would have got x squared plus 2x. And then we have is equal to negative 2. Now notice, we could keep going with this, and we could add 2 to both sides. And then that leaves me with x squared plus 12x plus 2 is equal to 0. Now notice, when we simplified this one, our highest degree was still degree 2. So in this one, guys, we would have 2 solutions. So just keep in mind, guys, there's lots of things here that we can consider. So we had a quadratic and a linear, and if you have a quadratic and linear, when you simplify it, you're still going to have 2 solutions because it's still going to be quadratic. So hopefully that helps many of you that had questions on, well, how many solutions am I going to have? Look at what the degree is, and when you simplify it, look at what the degree is, and then you can decide, okay, I'm going to still have 2 solutions or 1. Okay, finding the product of 2 polynomials. This was stuff that we needed to review. As I could see from the quiz, there was still a lot of miscommunication, misunderstanding here. So we're multiplying all this to all of this. That's what's important to understand. So I've taught you a process to make sure you go ahead and do this correctly, because we've got to focus piece by piece and make sure we multiply everything together. So what I would do is I would first focus on this first term 2x, and I would distribute it through to every term over here on the right. So 2x times negative 4x squared is negative 8x cubed. Don't forget the cubed, it's negative 8x cubed. And then 2x times positive 4x is, careful, positive 8x squared. And then 2x times negative 5 is negative 10x. Now notice I distributed my 2x through to everything on the left, so I'm good with that. Now we have to focus on our second term here, negative 3. Let's distribute that through to everything. Negative 3 times negative 4x squared is, careful because a lot of sign errors can happen, positive 12x squared. Negative 3 times positive 4x is negative 12x. And then negative 3 times negative 5 is positive 15. Then from here, guys, we're combining all like terms. I'm going to start with my highest degree, which is x cubed. There's only one x cubed is negative 8x cubed. No other x cubed, so I'm going to have that still. Now let's combine our x squareds. We have 8x squared and 12x squared here. And we're going to combine them so we get 20x squared, so plus 20x squared. Because they were both positive, so they added up to be 20x squared. And then we have negative 10x minus 12x. If we add this up carefully, we're actually going to have negative 22x's. Negative 10x's minus 12 more x's is negative 22x's. And then we have our plus 15. We combine all like terms. This is our answer. There's just a lot of room for error, as you can see, so you got to be careful, careful, careful. Okay, moving on. 6 over x is equal to x minus 1. Now, this is solving for x. This one's really tricky, and a lot of people got this one wrong on the homework. I was able to tell really quick that nobody understood how to do it, so we're going to go through it. Now, once again, we know that when solving for x, we have to combine terms. Well, over here on the left, what we technically have is 1 over x, and then on the right, we have an x. Now, these are not like terms. We can't just combine these. So we've got to go about solving this a different way. Now, notice we have 6 over x. X is in the denominator here. So we're dealing with fractions over here on the left. Well, we can fix fractions by multiplying both sides by what that denominator of that fraction is. Because think about it, guys. If we multiply both sides by x, then over here on the left, x over x is x divided by x. Anything divided by itself is a 1. So that divides out and becomes a 1, leaving me with 6. And then over here on the right, we have x times x minus 1. Now we have to be careful because we're multiplying x to all this side. So x minus 1. So we've got to distribute it through. So throw in parentheses. X times x is x squared. And then x times negative 1 is negative 1x or negative x. Now notice, this is a quadratic function. Now we can only solve quadratics a couple of ways. We've learned a few. We've learned how to solve by the quadratic formula. Quadratic formula always works for all quadratics. Or we can solve using factoring if it's factorable. So we've learned a couple different things. Now before we can get started with the quadratic formula or with factoring, we have to make sure it's set equal to 0. So I have to subtract 6 from both sides. Now notice that adds up to be 0, so we have 0 is equal to x squared minus x minus 6. Okay, so now we're dealing with a quadratic. Now once again, a lot of people like to bring these things over this way, which is fine, but then you end up with a negative in front of x squared, which makes it just a little bit harder. So I just decided I'm going to bring the 6 over this way onto this side of the equation so that I can keep in front of my x squared a positive, okay? All right, continuing. So now I can choose to solve by factoring or by the, if it factors, or the quadratic formula, which always works. I'm going to go ahead and use factoring because this one does happen to factor. Now remember, quadratics have the form ax squared plus bx plus c is equal to 0, where a, b, and c are the coefficients in front of the variables. Now I still saw people in the quadratic formula plugging in x's with their variables. You guys, it's the number, the constant number in front of the variables. So in this one, guys, we have a 1 in front of x squared, technically. We have a negative 1 in front of x, technically, and we have our negative 6. So a is in front of x squared, so a is equal to 1. B is in front of x, so b is negative 1. And then c is negative 6. There's our constant coefficient. So hopefully you see now where a, b, and c come from. So I'm just going to solve by factoring. So I'm doing what multiplies. So with factoring, remember that we do, I'm going to bring this up here. We're doing what multiplies to be a times c and adds up to be b. So a times c, 1 times negative 6. What multiplies to be negative 6 and adds up to be b, negative 1. So this is where we list out our factors of 6. 1 times 6 is 6 and 2 times 3 is 6. We've listed out all our factors that multiply to be 6. Now we have to decide which ones could possibly add up to be negative 1 if we put, we can put negatives with both of them, with just one of them. 1 and 6, no matter what we do, will never add up to be negative 1. 2 and 3, yes, it could add up to be negative 1, but our negative would have to be with our 3. 2 plus negative 3, so 2 plus negative 3 does equal negative 1. So it works over here, but we've got to make sure it works over here on the left. Does 2 times negative 3 equal negative 6? Yes, it does. So it works on both sides. So we know we're good. If it doesn't work on both sides, then it might not be factorable. Or you might have to choose different factors if it has the factors, okay? So it did factor. Our factors were positive 2 and negative 3. So now, once again, we write down the original equation, x squared minus x minus 6 is equal to 0. So we drop down our n terms. So drop and break is the next part. We drop down our n terms. So we have positive x squared and negative 6. And then we're breaking down our middle term. Now, I saw people doing this on the homework. They just put in plus 2 minus 3, because those are the factors. Well, you're off a little bit, okay? These were x's to begin with. They're still x's. We're just rewriting the x as positive 2x minus 3x. If you were to add those up, positive 2x minus 3x, you'd get negative 1x. So we're breaking down the middle term. So just don't forget those x's with those numbers. And now we group the first two terms and we group the second two terms. Then we focus on the groups and factor out everything we have in common. So we have x squared plus 2x. I'm going to scroll down, give myself some room. So we have x squared plus 2x. What do we have in common? Well, we have an x. So what's left on the inside? Now remember, if you pulled out an x, what you did was divided each term by x. So let's write what we have left. X squared divided by x is x on this term. And what's left? 2x divided by x. Those divided, so it's left with 2. Okay, moving on to my next group now. Moving on to my next group here. I'm going to pull out everything we have in common. And careful, we have a negative in front. Anytime we have a negative in the front, right next to the parenthesis, we've got to pull out a negative. So I'm going to pull out, well, 3x minus 6. I see they both have a 3 in common, so I'm going to pull out a negative 3. Once again, because we have a negative in front here, that's the only time we'll pull out a negative. So we're pulling out a negative 3, and we're writing what's left on the inside of the parentheses. Now, once again, you can go back through and say, what did I divide? I divided both things by negative 3 because I pulled it out. So negative 3x divided by negative 3 is just x. Negative 6 divided by negative 3 is positive 2. So left was x plus 2. Now you can check your safe haven. Is it the exact same? So there's our safe haven. And it is exactly the same. If even a sign is off, even if there's just a minus instead of a positive or whatever, you weren't safe. You didn't do something right, so you got to go back and check your work. But in this case, we're safe. We have our safe haven. So now we can pull out our safe haven. So we're pulling out x plus 2. So then they divide out, because we pulled it out, we factored it out, and left was x minus 3. All right, so now we factored it into our linear factors, guys, and our linear factors, as long as they're set equal to 0, any other number in this wouldn't work, but we have that it's equal to 0. We had taken care of that in the beginning of the problem, right? We made sure it was set equal to 0. So now you can take and split those apart. The zero product property rule says you can set each of those linear factors equal to 0, and then solve for x in each case. So from here to get x alone, I'm going to subtract 2 from both sides. X is equal to negative 2. There's one of my answers. We definitely know we're having 2 since it was quadratic. Add 3. X is equal to positive 3. There's my other answer. Okay. I solved by factoring. You could have used the quadratic formula. You'd get the same answer if you did the quadratic formula correctly. Because the quadratic formula always works for quadratics. And factoring won't always work, but we just do need to know how to factor. All right, rationalizing the denominator. So remember, the reason we learned to rationalize the denominator is because if you ever get an answer with a root of any kind in the denominator of a fraction, meaning bottom, you've got to fix it because it's considered not in the most simplified form. So we have the square root of 5 over the square root of 20. I need to get rid of the square root of 20. Well, look, let's look if we do this. If we multiply the bottom by the square root of 20, and then the top, if you do it to the bottom, though, you've got to do it to the top. So if we multiply by the square root of 20 over the square root of 20, think about it, guys. The square root of 20 over the square root of 20 is really equal to 1, right? Anything divided by itself is equal to 1. So right here, we're actually just multiplying by a fancy 1. So keep that in mind. That's why we can do it. We're just multiplying by 1. We're not changing anything. All right. And since on top here, okay, so then when multiplying fractions, we multiply straight across. Now, on top, since they're both under the square root, we can put them under the same root. So we have the square root of 5 times 20. And I'm not going to actually multiply those together because I'm going to have to break it apart anyways and simplify it. And on bottom, we have the square root of 20 times 20, which is 20 squared. 20 times 20 is 20 squared, guys. 20 times 20 is 20 squared. Okay, so now on the bottom, our root cancels out our power, leaving me with just a 20 on bottom. I'm going to come over here. 20 on bottom. And now on top, I have the square root of 5 times 20, which we've got to go off to the side and see if that simplifies any further. So now I'm just doing a little aside, and I'm going to break that down into its factor tree. So we have a 20 and a 5. So 20 times 5, 5 is 5. Its factors are 1 and 5, so I'm just going to write 5 because 1 times 5 is just 5. And then 20 breaks down into 4 times 5. And then 4 breaks down into 2 times 2. Now, since it's a square root, we're pulling out groups of 2. So we have 2 2s right there, 2 5s right there. So we're pulling out a 2 and a 5. Now, there was nothing left under the house. We pulled everything out. So there's nothing left under the square root. So we pulled out a 2, we pulled out a 5. So 2 times 5 is 10. So on top, this part, guys, this part simplified to be 10. So I'm going to erase that so I can write it pretty. So on top, we found that the square root of 5 times 20 is actually 10 because we simplified it. So now 10 over 20, if we were to type that into our calculator, we would get 1/2. You'd get the decimal, but then you change it back to a fraction. Or you can just say they both divide by 10. So this becomes a 1, this becomes a 2. So 1/2 would be our final answer. So guys, we started clear back up here, and this is actually the equal most simplified answer. They're equal answers, just 1/2 is the most simplified answer. So once again, the problem was the root in the denominator of the fraction. Okay. All right, so now we're going to be going ahead and solving for a variable in an equation. We're going to have some advanced equations here, so we're just going to practice this. The key is to remember to use the correct algebra to get from one side of the equation to the other. Do not break any rules, so don't skip and jump around without being able to do it. And then you've got to use the correct operation once again to get from one side of the equation to the other. So you'll need to remember your inverses. What undoes addition, subtraction? What undoes subtraction, addition? What undoes multiplication, division, and division undoes multiplication? So we're going to go through and start solving these. Now you have to do it in the correct order and piece by piece. So let's just start practicing. 4x minus 2y is equal to -7, so we're asked to solve for x. So I put x in red just so that we can keep our focus on x. Now let's do this in the correct order, piece by piece. So let's get x alone piece by piece. So I'm going to add 2y to both sides. Now you can check your answer. Over here on the left, I have 4x. Now you check and make sure, does -2y plus 2y add up to be 0? Yes. So we took care of this correctly. So we have 4x is equal to 2y minus 7. Guys, those are not like terms you can't combine them. 2y minus 7. Now we're trying to get x alone piece by piece. Don't forget the goal. So 4 is multiplied to x. So to undo multiplication is division. So we'll divide both sides by 4. 4 divided by 4 becomes a 1. Don't say 0. 4 divided by 4 becomes a 1. So we get 1 times x, which is just x. X is equal to 2y minus 7 over 4. There's our final answer. Now, don't make the error, do not make the algebraic error of saying, oh, well, 2 over 4, you can't do that, guys. It was the whole top divided by the bottom. So if you just divided 2 and 4 and put a 2, you were pretending like -7 here. This -7 wasn't being divided by 4, and it was. So unless all three things divide by something in common, you can't simplify it. So our final answer would have been 2y minus 7 all over 4. Okay, solving for a in the equation. So piece by piece, we've got to do this correctly. We're trying to solve for a, that purple a there. So the first thing I'm going to do is I'm going to subtract 10 from both sides of the equation. So over here on the left, we can't combine b's and numbers. So b minus 10 is what we have, which is equal to a squared. Now to get a completely alone, that's a squared, not a. We've got to take the square root of both sides. So then over here on the left, I have the square root of b minus 10. And then over here on the right, my root cancels out with my power, leaving me with a. But then remember, guys, when you take the square root of both sides and you're solving for an equation, you can't forget the plus and minus answer in front. Now we talked about why that is, because let's say our answer would have been -2 squared. That's equal to 4. Well, that's the negative solution, but also the positive solution, +2, would have also been equal to 4. So that's why we have to account for the plus and minus answers when solving, and we take the square root of both sides. Okay, so because anything squared, that is the inverse of square roots, and that's what square root means. It means what squared is equal to our answer. So we have to account for the plus and minus answer. Now we could have written it a little bit prettier and said a is equal to plus and minus the square root of b minus 10. Same thing, I'm just writing it a little bit prettier. Okay, there's our answer. Next problem here. Okay, we're going to get more advanced here. So we're going to solve for a variable, solve for x. So there's many different ways of doing this. I have to be clear on that. There's so many different ways of going about solving for this. So it just kind of is personal preference, and they come with practice. So with this one, the class decided that they wanted to distribute this one through. First, so over here on the left, we're trying to solve for x. The class decided that they wanted to distribute b through to both these things, which was a good idea. So I'm going to have bx plus 5 times b is 5b's. So we have bx plus 5b's is equal to 25. Now, piece by piece, we're trying to solve for x. We're trying to get x alone. So I'm going to subtract 5b's from both sides. So over here on the left, I have bx. Those better add up to be 0, and they do. So I've done this correctly. Bx is equal to 25 minus 5b's. You can't combine them. They're not like terms. So 25 minus 5b's. Now, once again, piece by piece, we're trying to solve for x. Last step, divide both sides by b. So then those b's divide out. And I'm just going to erase that so it's prettier. Those divide out to be 1. So now look, guys, x is all by itself, completely alone. So we solved. We are done. We solved for x. Now, once again, don't make the mistake of saying, so this is our final answer. So watch this. Don't make the mistake of saying, oh, b and b divide out. Well, you pretended like that 25 wasn't divided by b, and it was. It was all that stuff divided by b. So please just be really careful with your algebra and simplification. Okay, getting more advanced here. AC times x minus 2 plus 5. So AC times x minus 2 plus 5 is equal to 3x. Now notice I have some x's on the left and I have some x's on the right. Well, we're going to go through and do this correctly, piece by piece. So the class said, well, let's distribute AC through, and I thought that was a great idea. So AC times x is ACX. AC times negative 2 is negative 2 ACs. And then don't forget about the plus 5, which is equal to 3x. Now notice I have an x, an ACX over here on the left, a 3x over here on the right. Those are not like terms. Those are not like terms, but they both have an x in common. So what I would suggest from here is bring all your x's over to one side of the equation and take anything else over to the other side of the equation. So I'm going to first of all add 2 AC's to both sides. I'll show all my work on this one. So over here on the right, I have ACX, and then those add to be 0 plus 5 is equal to 3x's plus 2 AC's, can't combine them, so we have 3x plus 2 AC's. And then showing my work, once again, I'm going to get subtract 5 from both sides. And once again, I have ACX on the left, those add up to be 0, which is equal to negative 5 isn't going to combine with 3x or 2 AC's. So we have 3x plus 2 AC's minus 5. Now remember, we're trying to solve for x, and we can't forget that we have this 3x here. So we need to bring the x over with the other x's. We have an ACX over here on the left. So let's go ahead and bring 3x over, but we got to do it correctly. So I'm going to subtract 3x from both sides. Now notice, over here on the left, we have an ACX minus 3x, not like terms, so we can't combine them. So we have ACX minus 3x is equal to, those add to be 0, and we have 2 ACs minus 5. Now notice on the left, I have everything with an x over here on the left, and everything that doesn't have an x over here on the right. Okay, so now, if you focus your attention here, this is kind of cool. Over here on the left, we have something in common in both terms. They both have an x in common. Well, if you ever have something in common in two terms, you can factor it out. So I'm going to pull out an x out of each of those things. Now I've got to write what's left inside. So if I pulled out an x, I divided each term by x. So left in this first term is AC, and then left in the second term is minus 3. So we have that is equal to 2ACs minus 5. Now from here, it's x times all that stuff, right? X times AC minus 3. Well, undoes multiplication division. So look, if we divide both sides by AC minus 3, you have to do it to both sides. AC minus 3. Then on the left here, those will divide out and become 1. So we'll just have x times 1, which is just x. X is equal to 2 ACs minus 5 all over AC minus 3. Now notice you can't divide out the ACs because it's 2 ACs minus 5, AC minus 3. that AC minus 3 is connected. We can't just start dividing out things. You can't just split it up and say, okay, the AC is divided to just the AC. The two ACs on top are divided just to the ACs on bottom, and the -5 divides by -3. No, it's all 2AC minus 5 divided by AC minus 3. So each of those things are divided by 2AC minus 5. 2AC is divided by AC minus 3. And -5 is divided by AC minus 3. So really, this is our final answer. This is the furthest we can go. Next one, getting a little bit more advanced here. A times x minus 3 plus 50 is equal to cx plus 5. We're solving for x. Now, once again, I see I have an x on the left and the right, so I'm going to go ahead and distribute here. There's a lot of different ways of doing this one, but I'm going to distribute. So I have a times x, which is ax, a times -3, which is -3a. So we have plus 50 is equal to, I'm going to distribute 3 through cx, and then c times 5, which is 5c's. Now, once again, I have a bunch of different x's, different types of x's, and a bunch of different other things. I would bring all x's over to one side of the equation and anything else over to the other side. So I'm going to subtract cx from both sides. Now, over here on the left, I have ax minus cx. Can't combine them, they're not like terms, but I still have my -3a's plus 50. I have all this stuff, guys. It's the same thing I just wrote. I just wrote it in a line, so it's pretty. You can't combine any of that stuff. And then over here, those added up to be 0, so we took care of it correctly. So all we have left on the right is 5c's. Now let's isolate the x's. Let's get them all alone. So I'm going to add 3a's, and I'm going to subtract 50. Now those are both inverses. We have to do both sides the same exact thing. So add 3a's and minus 50. Now look what happens here. Make sure those add up to be 0. Those do add up to be 0. Those add up to be 0 as well. So I applied the inverses correctly. So on the left, I have ax minus cx is equal to, now over here on the right, I can't combine any of those things. They're not like terms. So 5c plus 3a minus 50, that's all I can do is write it in a line. Now on the left here, we have something in common. We have an x in common. We have an x in common, so I'm going to factor out an x. And then left is a minus c. Once again, you have to go through and go, okay, I pulled out an x, I factored out an x, so I divided out an x out of each term, leaving me with a minus c. You can go ahead and do that. Which is equal to 5c's plus 3a's minus 50. And now we're going to get x alone. Now x is multiplied to a minus c, so what undoes multiplication division. So we'll divide both sides by a minus c. So that becomes 1. So x is now all by itself. Now if you don't mind, I'm just going to erase that so I don't have to rewrite it again. So we get x is equal to all that stuff. Once again, there's nothing in common with all terms that divide out. So this answer would probably be the simplest we'd go. Okay. All right, last one or so. Here we go. So we have 2b over x minus 3 is equal to a. Now, with this one, we're dealing with fractions. We only have one x, but we're dealing with fractions, so you got to be really careful. A lot of people are like, okay, I'm going to subtract 2b from both sides. Well, guys, you can't subtract 2b. It wasn't being added to x plus minus 3. Subtraction undoes addition, and addition undoes subtraction. So there's a bunch of different ways of doing this one. But what I'm going to do is just go ahead and say, okay, I don't want to deal with fractions that much. So I'm going to go ahead and multiply both sides by x minus 3 because I have a denominator of a fraction. So if I multiply both sides by x minus 3, then over here on the left, on top I have an x minus 3, and on bottom I have an x minus 3, so they divide out and become 1. So that leaves me with 2b is equal to a times x minus 3. Now we're trying to solve for x, so let's distribute that through. A times x is ax, and then a times -3 is -3a's. And now from here, piece by piece, I can solve for x. I only have one x. I have the ax, and so I'm going to get that along piece by piece. Add 3a to both sides. You can't combine 2b's with 3a's, so we still have 2b's plus 3a's, which is equal to ax. And now we're trying to get x alone, so we'll divide both sides by a. Both sides by a. Now okay, those divide out, so we get x is equal to, we have 2b's plus 3a's over a. Now, let's see if we can simplify anything. Well, these two have an a's, 3a's over a's. If you divide those out, though, you just pretended like 2b wasn't also divided by a, and it was. So there's nothing in common with all three things here. So this would be how you leave your answer. Okay, last one here. We have solve for x. We have 25 ab's over x is equal to x. Once again, we do have two x's. They're not like terms though right now. So what we would do is I would get rid of the fraction. So I'd multiply both sides by x. So then x divided by x and is gone. So we have 25 ab's is equal to x squared. And then to solve for x, to get x alone, well, this one's unique. To get rid of the square, we can take, since there's no other x's, or x is out here. If there was, you couldn't do this. But what we can do is, since there's only an x squared, we can get rid of the square by taking the square root of both sides. So the square root of 25 ab's, which is equal to the root cancel out the power and x. And then we don't forget that we always have the plus or minus if we take a square root of something when we're solving. So this would be my final answer here. All right, go ahead and finish up the back of the worksheet 1-5. Make sure you can do the front too. Do not skip domain and range. You guys need to be able to do those. You should. There's a video on domain and range as well, so watch that if you need to. Finish up that worksheet.